In this module, we're going to take a look at Singapore math. I'm just referring to it as Singapore math, but really the math that I'm explaining here is found in other curriculums. However, in Singapore textbooks, you will definitely find information about number bonds and bar models, also known as like unit bars or model drawing. So because it's definitely recognizable in Singapore, so we're just referring to it as Singapore math for right now. All right, anyway, so the first thing that we have posted there is on number bonds. Number bonds are really important for making number sense and for building the basic foundational skills, really, in order to be able to understand how addition and subtraction work, and even multiplication and division, so all our basic operations there. So this here is an example of number bonds. Number bonds are made up of a part, and a whole. So you can really see here that, so we have our whole number 7, and that the parts that could possibly make up 7 would be 5 and 2. Now, obviously we could have other parts in here, right? We could have 6, and we could have 1, we could have 3, and we could have 4. But this is a way of modeling on paper the part-whole connection. So what we would actually do with students initially, though, is with using manipulatives, we would end up introducing number bonds with those manipulatives to develop a concrete understanding of how the relationships between numbers work. So there's a couple other videos that are posted in how to do that with the manipulatives. But just for example, you know, if you were to give the students, you know, 5 different Lego blocks and say, all right, so we have 5. How, you know, how many, which ways could we divide up these 5 blocks? Like, so if you and a partner had those 5 blocks, how many blocks would you get, and how many blocks would your partner get? All right, and I'd have them play around with the blocks and kind of see how many different number combinations could they come up with. You know, using those Lego blocks. We would then take what we've done with the manipulatives and plug it into the circles here for the part-whole. And it doesn't matter if they're written like, I've seen it written with a whole part written on the top versus the bottom. Over this one that they're showing you on the side here. So your whole number's 5. Your parts are made up of 2 and 3. You can kind of see how this lends itself to then working on addition and subtraction problems later on, that you know, your parts, you certainly could add them together and get 5, or if you have take your whole, right, and subtract one of the parts, it ends up getting you the other part. So you're talking about those kind of relationships. So this article here kind of talks about going from the concrete to the pictorial to the abstract. Sometimes you'll see that in literature written as a CPA, the CPA approach. But the concrete would be starting out with using the manipulatives, things that the children are familiar with, and then going to the pictorial, which would be like drawing out the number bonds, and then finally the abstract, which would be like actually writing out the equations. So they give you some examples here of kind of how that all works. There's a video here. Dr. Yip is famous for the Singapore math and the number bonds and putting out information there, so he gives you an example. And then this is probably the one where kind of taking it a step further with number bonds. This is the one that always like throws the parents off, or is like, why are they teaching it this way, sort of thing. But being able to recognize that 60 is not just 60. 60 could be, you know, 3 and 57. So if you're adding more complex numbers or larger numbers, sometimes it's easier if you can think of a way to get to the 100 to be able to add up, right? So if you took 297 and added 3 from the 60, that would get you to the 300, and then all you have to do is tack on the 57. So that's just one example of kind of how they start to take it to the next level. I have some other things there too about number bonds. There's a blog post by a mom who kind of shows how she uses number bonds with her son, and he's included in there. So I thought that was nice to see a student actually working with the manipulatives. So that's the good, bad, and ugly of number bonds. There's another article here about teaching number bonds. And then there are a couple of videos that demonstrate how you would use number bonds in the classroom so that you can actually understand how to do that. And then, so moving from number bonds, the next thing is this idea of bar modeling, or unit bars, they're sometimes called. So here's a document that kind of explains the bar model process. It's actually considered a problem-solving strategy. So this is the steps for the problem-solving strategy first. So you read the entire problem. One thing that they encourage is to rewrite the question in sentence form, leaving a space for the answer. This is a really good strategy because it encourages the students to really focus in on what the question is asking them to solve for. And one thing that is a good habit for them to get into is being able to write their answers in a sentence, as well as including units, because again, it's a way for them to fully explain their work. Step 3 is to determine who or what is involved in the problem. Step 4 is drawing the unit bars, which we will take a look at in a second. Step 5 is chunking the problem, or adjusting the unit bars and filling in the question mark. So we talk about like identifying unknown values within the word problems. And then 6 is to correctly compute and solve the problem. And then finally, number 7 is to write the answer in the sentence and make sure that the answer makes sense. And that's just one problem-solving strategy there that's included, but that's very typical that you would find in like a Singapore math book. If any of you purchased the workbook that I had suggested called Step-by-Step Model Drawing, that's actually one of the pages from in there. And there's some great problems in there for helping you to learn how to use unit bars. All right, let's see. Okay, so this is the document that really demonstrates the process of using unit bars. They kind of give an explanation as to why they're helpful, but it really is it kind of bridges that gap between going from the conceptual to like the abstract. Again, there's a little video there that he kind of explains how to use unit bars. But what I like about in this article is if you scroll down here, is again talking about providing examples of concrete modeling with real objects, and then going to pictures. All right, and then eventually when we're looking for unknown values, right, they're also showing that. Here's a number bond again, that they're showing how that's related to going from the concrete to pictorial, the number bonds. And then down here we can start to see how we're taking the concrete and missing information and turning it into, this would be an example of a initial unit bar. So we're still talking about part whole. So that's the nice thing with going from the number bonds to unit bar models. We're still, we still got our purple section, which is a part. We've got our yellow section which is a part, and together the whole thing is 20. So again, they're showing you even further here, and we would actually, in some classrooms, you might actually be lucky enough to have these building blocks that you can easily use to create unit bars, which is helpful because they'll use those with the number bonds, and then you can use them as bars, and then eventually with just drawing, it gets the kids in the habit of just drawing the actual bar itself, and then no longer needing the manipulatives. So they're going from the concrete to the pictorial, and then applying it to the abstract. So it kind of explains that. There's another video there for you to watch about that. And then the last article is also just another example of using the unit bars, using model drawing. This also is a nice leadway into algebraic concepts with finding unknown values. So again, just some more examples here of a pictorial understanding of how to use unit bars. there's a lot of different lessons on ways in which you could use unit bars, especially when it comes to, you can use it for all of the different operations. You can use it for fractions. They're really great for using with ratios. So there's a lot of different strategies. I'm not going to be able to obviously share with you all of them, but I wanted to at least pique your interest in that, this is a model that's used for problem solving. And like I said, if you're lucky enough to have purchased the book Step-by-Step Model Drawing, there's a lot of examples in there for you to refer to. All right. In this article, like I was saying before, this kind of guides you in understanding how eventually unit bars would be applied to algebra. Okay. If you have any questions, you are free to reach out to me. Okay. Thanks so much.